Hello, pre-calc. So this is going to be kind of a long lesson. I've broken it into 3 pages so that you might want to just do a page at a time. And this will be on our next quiz and on the test, so it is kind of an important topic. All right, so we're going to start off with this first example. We're just looking at a function and we want to identify the domain of the function because that tells you if you are graphing something, whether it's defined or not within that interval. So when you have a rational algebraic, what you're really looking at is your denominator, since you can never divide by 0. And so in this first fraction, we see 2x squared plus 3. Since x is always being squared and then we're adding something, this one actually, there's no way you can set it equal to 0. So the domain is going to be all real numbers. So remember, that's what that little r represents. All real numbers. Now, if you have, as in this next example, a quadratic, you are going to have to go ahead and factor it. Factoring is going to be really important, especially in this section. So just to remind you, since a is 1, so a times c is what goes on top, so that's just going to be a negative 15. The middle term, negative 2, goes on the bottom. What times what is negative 15 but adds up to a negative 2? That is going to be a negative 5 plus 3. And since a is 1, those are the numbers that would go into that. So x minus 5, x plus 3, that's how your denominator would factor, which means our domain is going to be all real numbers except x cannot equal a positive 5 because that would make that factor 0, and x cannot equal a negative 3. Whatever makes the denominator equal to 0 has to be restricted because that would be a vertical asymptote. All right, so that's just for identifying the domain. Now we want to be able to just work with these, so a little bit of a reminder when you're working with these rational equations. I'm going to, so this is division, which means you invert and multiply the second equation. So as I rewrite it, I'm going to also factor. So my denominator, I can factor out a 2, and then we turn this into multiplication. So the numerator from that second one goes downstairs, and I'm going to factor out an x. And the denominator now is going to go upstairs. So what times what is 30, but adds up to a negative 11? So that would be a negative 5 and a negative 6. So once we do all our factoring, I can now start to simplify anything on top with anything on bottom. And we have this little x here that goes away. And this whole thing simplifies to a very lovely 7/2. And we're done. Okay, now we are going to add and subtract, which is always a little bit harder because it means you have to have a common denominator. And so to see what that common denominator might be, I'm going to go ahead and factor things and then rewrite this. So I have x plus 2 over 2 times x minus 1. And we're going to be subtracting. On top we have here negative 2x minus 1 over, in factored form, so what times what is 3? Positive 3, but adds up to a negative 4. This would be a minus 3 and a minus 1. All right, so we want our two denominators to be exactly the same. So at least they both already have this factor in common. My first fraction has a 2 that the second one doesn't have, so I'm going to multiply top and bottom by 2. And my first fraction does not have the x minus 3, so I'm going to multiply top and bottom by x minus 3. Now we have the same denominator on both fractions, which means that part of this is done. So my denominator, my common denominator, is this. Doesn't matter the order you write it in. And now I have to distribute and simplify my numerator. So this first one I'm going to have to FOIL. So I get x squared. Outer and inner, I like to just do them at the same time. So that's 2x minus 3x is minus x. And then the last term would be minus 6. And now I have a minus, be very careful with that, and this has to distribute. So I'm really distributing a negative 2. So this first term will be a positive 4x, and then negative 2 times a negative 1 is a positive 2. All right, so we want to simplify that and see what we end up with. I'm going to do it right above it. So this gives me x squared. I have minus x plus 4x, so that's going to be a positive 3x. And minus 6 plus 2 is a minus 4. And so we want to see if we can factor that. So it turns out that that is factorable. So that would be, let's see, we want a positive 3, so it's going to be plus 4 minus 1 all over 2 times x minus 1, x minus 3. So we're almost done because this factor now cancels, and our final answer would be x plus 4 over 2 times x minus 3. You can leave it in factored form, and we're just going to acknowledge that x cannot equal 3. And I'm looking at my answer key, and I did something wrong on the answer key. This one is correct. Okay, awesome. That is just kind of like a little review of stuff that you did way back in A2A. Now for something completely different. Okay, partial fractions. Now, this really won't come up until Calculus BC, though I think some of the AB teachers cover it a little bit, and it can get quite involved. It's doing what we just did backwards. What that means is we took two rational terms, and using common denominator, we made it into one. What partial fractions does is it takes one equation and it turns it back into two equations. And the reason why you would want to do this is because when they are separate, they're more simple and easier to work with. You'll be doing something called integration in calculus. So this is one of the reasons you want to be able to do this. Now, there's a long way to do this, and there's, of course, is a shortcut way to do this. So I'm going to do the long way first so that you understand the why, and then we'll show you the shortcut, which is like boom, boom. All right, so we're taking this fraction, 8x, whoops, I need a pen to write with, thank you. So we have 8x minus 1 over x plus 4 times x minus 7. And we want to break it up into two fractions. So I know that one of the denominators will be x plus 4. One of the denominators will be x minus 7. I do not know what my new numerator will end up being. And I'm going to go ahead and just put a plus here. Maybe b is positive, maybe it's b negative, it'll come out. So what we're going to do is we are going to create the common denominators and set up a system of equations. So what we know from our original is that this was x minus 7 over x minus 7. That was our original common denominator. This one was x plus 4 over x plus 4. Okay, so now when we look at this, what we know is my two denominators, or all three denominators, are the same. So I only have to focus on my numerator. Now, okay, so how does this work? I'm going to pull down my numerator here. Here's 8x minus 1, and I'm going to just distribute so you can see kind of what I'm getting at here. I have on that first fraction, I have ax minus 7a plus bx plus 4b. All right? So what I have done is just, I don't have to focus on the denominators anymore because they're all the same. What I am going to do to solve this, so anything with an x is going to have to be equal. So I know that 8x has to equal a plus b times x. So I just factored out the x of those two terms. So the x terms have to be alike. Now, my constant, the -1, that's going to equal my other two, because a and b are just numbers. So this is going to equal, I guess I can factor it out or I can write it as is. I guess it doesn't matter. Maybe I will. So I have, no, I'm going to write it down. Sorry. -7a plus 4b. All right. Okay. Well, we have ourselves a potential system here, and I would like to solve for A or B, which means I would like one of them. Okay, so what I'm going to do, since I know that this has to equal this, I'm just going to write it with the number 8 equals A plus B. We can kind of drop the x because it's the coefficients we want to set equal. So at this point you have a system of equations. What I'm going to do is I'm going to multiply down here by a -4 so that I can get rid of my b value. So now when I add these together, that goes away, and I have -32 plus a -1 is a -33 equals a -11a, so that gives me that a is going to be 3, and then I can go back and substitute. If a is 3, that means b has to equal 5, because I know that 3 plus 5 has to add up to 8. So I was just looking here. So then writing it as a final fraction, which I'm kind of running out of room here, is we would have 3 over x plus 4 plus 5 over x minus 7 would be the equivalent of our original function, algebraic function. Okay? Now, that was a lot of work, wasn't it? Ha ha ha, she says. Because I know that, now you don't get to see this. This is kind of upsetting that I can't show this to you with my hands. But there's actually a really, really, really fast shortcut for this. And the shortcut doesn't make sense if you haven't seen how we did the breaking it up. So the first thing you do is just start off the same way we did. So this would be x plus 4, and we want to solve for a and b. All right, so instead of going through the whole common denominator thing, what I'm going to do is you look at this and you see, okay, what would make this denominator 0? And that would be a -4, right? Let x equal a -4. Well, obviously we're not going to actually let x equal a -4. But what I'm going to do is I'm going to let x equal a -4 over here, and this is the part you don't see. I'm actually going to cover this up. I'm not doing it on that one. So I'm plugging in 8 times -4 minus 1 over -4 minus 7. And that gives me 32 minus 1, which is -32 minus 1, which is a -33 over -11, and voila, we got a is 3. Magic. Okay, now I want to make sure my x plus 4 is still there. So let me go back, put in my x plus 4. Now we're going to do it on b. So we always let what would make this denominator 0. Let x equal 7. but I'm not doing it there, I'm doing it on the original fraction. So again, you are not going to do it on this term. So what I'm doing is 8 times 7 minus 1 over 7 plus 4. Well, that's 56 minus 1 is 55 over 11. Voila, B is 5. Now, usually what we do, this is called the Heaviside method. And what you really do, instead of that crossing out, you just cover it with your finger. You cover the x plus 4, you cover the x minus 7 in the original one, plug in the value that makes that fraction 0 in the denominator, and there's your answer. So you can see we got exactly the same with a little bit less work, just plugging in what would make the denominator 0, obviously not into the factor that would make it 0. Okay? You're going to try this on the next page. Okay, on this page, you're going to do the same thing, but we're raising the stakes a bit because you're going to have to factor the denominator before you can use the Heaviside method. So you can either watch while I factor and then try it on your own, or just go ahead and try it on your own. So notice this first term, we're not making it easy on you. So A is 2, C is negative 5, so that product goes on top. Negative 9 goes here. What times what is negative 10 but adds up to a negative 9? That's a negative 10 and a positive 1. However, that's not what goes into the parentheses. What goes into the parentheses is this will be, the first term has to be a 2x and an x. That's the only way you're going to get 2x squared. This is where I do my little double rainbow. So 2 goes into a negative 10, so that one goes here. And then the positive 1 goes on this one. So you have to ask yourself, 2 times what is a negative 10? Well, that's going to be minus 5. And then 1 times what is a positive 1, so that's plus 1. That's how I factor. All right, so I know that this is going to be A over 2x plus 1 plus B over x minus 5. So I break it up into its two fractions. So for this first one, I'm going to let x equal a negative 1/2 because that's what would make that denominator equal to 0. So going back to the original function, I'm plugging in a negative 1/2 in the numerator here, and then only in the x minus 5. So this is a negative 1/2 minus 5. I kind of gave you some ugly numbers here. So I have negative 1 plus 23. Well, that's 22. On the bottom, we've got a negative 5.5. And believe it or not, if you divide that out, it gives you a very friendly negative 4. So A is a negative 4. And then for B, we're going to let x equal 5. So 2 times 5 plus 23 over now 2 times 5 plus 1. So 23, that's going to give me 33 over 11. So B is going to be 3. And that would be your solution. Okay. Now again, let's try one more. Notice, oh my gosh, she's making us factor a cubic. Is she crazy? Well, yes, but that's beside the point. We want to find a factor of this, so I'm going to do my little, let's test f of 1. Do our little p of q, so we're looking at factors of negative 12. I always start off with the lowest. So that's 1 minus 8. That's a negative 7 plus 19 would be 12 minus 12. Voila. Awesome. So let's synthetically divide into this. So we have then 19 minus 12. Bring down the 1, negative 7, negative 7, which is 12. So we got our 0. So this is going to be x squared minus 7x plus 12, which we can now factor. So that's x minus 4, x minus 3, and we had a factor of x minus 1. So this puppy is going to factor, I'm going to put it right below. So x minus 1, x minus 4, x minus 3. And so I have 3 factors. Well, that's okay. It doesn't matter which one you do, what order, it all comes out. So A will go over x plus 1. B is going to go over x minus 4. And C is going to go over x minus 3. All right. So at this point, maybe you should go and try it on your own just to make sure you do. Stop the video for a sec. We can come back after you're done, but I'm going to keep going. So I'm going to let x equal 1. So I have negative 3 plus 22 minus 31 over, and I'm only going to plug it into the second 2 factors. So 1 minus 4 is a negative 3 times 1 minus 3, which is a negative 2. All right, so let's work this out. I have 19 minus 31, which is negative, so that's going to be 9. This is a negative 6. You know what? Just in the interest of time, because I don't want to make a mistake and then have to backtrack. Oh, no, I entered something wrong. Oh, poo. Don't you hate it when you enter something wrong on your calculator? All right, so that's a negative 12 over a negative 6. So I know that A is going to be 2. All right, now I'm going to do this one. So I'm going to let x equal 4. So negative 3 times 16 is a negative 48, plus 22 times 4 is 88, minus 31, all over. Now I'm only going to plug it in the first and the last. So 4 minus 1 is 3, 4 minus 3 is 1. So I have negative 48 plus 88 minus 31 is 9 over 3. So this value will be 3. And then the last one, I'm going to let x equal 3. So I have negative 3 times 9 is a negative 27, plus 66 minus 31. And since I'm plugging in 3, it's going to be the first 2. So 3 minus 1 is 2. 3 minus 4 is a negative 1. So negative 27 plus 66 minus 31, I get 8 over a negative 2. So C is going to end up equaling a negative 4. And that's how that would work. Okay, now that was the easy version. Notice none of our factors were the same, nothing was squared. So on the next page, you're not going to be able to use what is called, again, the heavy side sort of shortcut. You're going to have to use systems of equations. So you might want to take a break and come back, and we will do the long version on the next page.